So this week I've managed to get the B-tree deletes working, and I think this week what I'm going to try and do is talk through the three main operations of the B-tree, or four if you count updates and inserts as different things. A seek of a B-tree involves looking at the root record and trying to find the key, and then progressively working down the tree until you get to a leaf node. And then when you get the result, what's nice is if you have the path that you got to that root node in the iterator, which is what I've returned there, then you can use it for the very next operation and start working on the node that's important instead of having to seek through the tree a second time. So that was my main point that I was trying to get working there. For an insert or an update, so an insert, you're expecting that the record doesn't exist, and an update, you're expecting that it does, but otherwise they're more or less the same. For an insert, there is a chance that you put in a record and it's too big for the node. And when I say it's too big, the nodes are meant to fit inside of a disk block. So in this case, it's 4096 bytes. In the test code that I've written there, I've got entries that are 816 bytes wide, so 800 bytes for the key and 16 bytes for the value that goes in there. And that is intentional because the value is going to be 16 bytes wide, even if it's an offset, like if it's a branch node and it's pointing into the other record type, the leaf nodes. So yeah, if it's larger than that, and in this case it will fit five keys and values. If you try and put a sixth one in, well, now you've got too many, so you need to split that node. And splitting a node will then cause a second entry to be put into the node above that record, which may also provoke a split all the way up to the root. And if your root node needs to be split, well, now you need a new root, which will have two entries in: the node that you already had and the new node. So there's that working. The seeks, inserts, updates, although I feel like I need to spend a little bit more time testing the updates. And then today I've finally got the last of the weird things that I noticed on the deletes. So deletes turned out to be way more complicated than I expected, and the main reason for that is that when you remove a record from a node, like if it's a leaf node, it might mean that the node adjacent needs to be merged with it. So you get down to a low watermark size of a node, and if it gets to that small, well, you start looking for other nodes. That might mean that you need to look at the parent node and what's the next node, or what's the previous one if you're already at the end of the collection, and merge with that other node. And if you merge with that other node, well, that node might be big enough that you then need to split again. So you end up with an even number, or very close to even number of records in the node and the node that you merge with. Or you might only have enough records that it fits in an entire node, in which case you need to delete the other record. So both of those operations might have to then be sort of fed up the tree. And we've got the added complexity that, well, some of those nodes that you're merging with or updating or whatever may have been from a previous transaction, so you need to copy that change into a new node that then you have to pass the offsets up to the parent node as well. So yeah, so that was all very complicated. It took a long time to get right, but I think it's working pretty good now. I feel like it's not ready for general use yet, but it's getting very close to the point where I would say you could use this B tree and be relatively confident with it. And I hope to be able to say that next week. And then the next steps are, okay, well, I'm going to have to build something out of these B trees. So watch this space, and I'll talk to you next time.